Today I'm going to give you a short brief overview of expert elicitation methods that can be used out there to quantify uncertainty. Key theme in all of them is you elicit experts with the aim to quantify the uncertainty, and you will always provide a probability distribution with no uncertainty about its exact shape. So what do we mean by expert elicitation? Let's clarify our jargon. It's the process to aggregate estimates from a panel of experts. Is it useful? It's been widely applied from 50s onwards as a tool to assist decision makers when there are no data available or where the models can be trusted. It has been used in cases of emergency. A very recent one was during the pandemic. Do we open primary schools? Do we not open? What does it mean about the contact of small children? There was an elicitation. What are the key challenges? So we put the experts in a room. What do we ask them? We ask them to adequately account for the uncertainty. Yes? No one estimates we want some kind of estimate of the uncertainty we have until the golden moment we get our data or we trust our model. What is the main problem with that? Experts are not very good at it, or humans are not very good at it. There are also all sorts of cognitive biases that will hinder our efforts. Anchoring and adjusting, you have to be very careful with how you frame the problem. You put a number there, experts will anchor their opinions around this number, and they will adjust accordingly. You don't want that. If again the discussion is around frequency of events, if something comes to mind, they are more likely to say that it will happen than if it doesn't come to mind a particular event. And they tend to be, some of them anyway, overconfident. They think the uncertainty is too small.
I can hear you very well.
Yeah, thank you. Overconfidence, listen. So, no matter what kind of method you are going to use, if you have to consult your experts, the main thing you have to do is prepare. You need, I think, a team to perform a successful expert elicitation. You need someone that owns the problem and knows very well the literature and will do an extensive background review on the literature. And so what is known is very, very clear and very relevant for the meeting. And then you have the facilitator, the one that is very familiar with the protocol you're going to use and will try to make sure that cognitive biases are as limited as possible. Again, you need a few runs with a few experts or the whole panel of experts. You need to make sure that the questions are being framed unambiguously, not straightforward at all in the first instance, but after the fifth iteration, everything looks very clear. To identify suitable experts and convince them to come to your workshop, a non-trivial task in any shape or form. You need multiple experts. One is not enough, or two is not enough. Let's say 4 and above, depending on the method you use, but definitely 4. And you need to make sure that you cover diversity, the diversity of backgrounds that there are out there. If you have different schools of thought, please invite them. And make sure they are represented. And then you have to stick to a given protocol, set of instruction of how to construct, how to elicit the opinions and how to aggregate them. in order essentially to reduce as much as you can the cognitive biases. How do we reach a consensus? We have, let's say, 5 experts in the room. All backgrounds are represented. How do we aggregate their opinions? Do we need to aggregate their opinions? In most cases, we do need to have a conclusive answer, yes, no. Or we need to aim to construct a single distribution. There are 2 different protocols. We can have behavioral approaches in which the experts interact with each other and reach reach a consensus by reviewing each other views, either by discussion or anonymously. The 2 widely used methods is the Delphi method and the Shelf method, the Sheffield method. There are mathematical approaches. Experts do not interact in the responses. But the analyst gets the different views, goes away, and mathematically aggregates their opinions. The most widely used method in this approach is the Cook's method, the classical model for expert elicitation, as it's called. The result, no matter which method you're going to use, is going to be a rather precise probability distribution. As I give you an overview, I'd like you to have these 4 attributes in mind in order to understand where the different methods come from and where do they score high, where do they score low. And these are their accountability. At the end of the day, you want someone to hold accountable if results are contradictory or they don't agree with logic or whatever. You want someone to hold responsible. As Roger Cook gives the definitions, the source of expert subjective probabilities should be identified. Fairness, all experts, at least at the beginning, should be treated equally prior to processing their opinions. Neutral, that's a bit complicated, and that's the main problem with behavioral approaches, as you will see, is which method do you use to combine expert opinions, and how do you actually encourage the experts to state their true opinion and not yield to the pressure of the group? Finally, it's empirical control. Ideally, you would like to be able to assess how good the expert is in quantify the uncertainty to some data. Of course, if you had data, you might argue you wouldn't need them in the first place, but let's see. Let's start with the behavioral approaches, the Delphi method. The experts do not need to meet in person, but it does require to have multiple rounds of elicitation. In the first round, you present the experts with a problem and the questions for which you want their opinions, and they provide their opinions. The Delphi method has not been used so much for, it has not been initially developed to assess a certain uncertainty, but you can ask the experts to construct a distribution in any case. It can be adjusted. Now, they give you their views. In the next round, you present each expert with the anonymous results and feedback of the previous round. Yeah? And they are free to modify their opinions or justify their deviation from the majority, if there is a majority and there seems to be a consensus. And you repeat that until you get a consensus. At least 2 rounds, I would say. Now, how do you combine the opinions? In the literature, you might see equal weights. All experts are on equal standing, equal weights. You just get an aggregate average. You can ask the experts to apply self-weights. I know what I'm talking about. I'm kind of knowing what I'm talking about. I have no idea what I'm talking about, probably. Or you can ask them to weigh how good the other experts they think they are, that kind of de Groot weights. Now, what is the main challenges with using this behavioral approach? You have this, there is conflicting evidence about how good this method is, but the critical studies say that they tend to suffer from conformity to the majority position. So the consensus is not a real consensus. It's not their true beliefs, but they feel they're obliged to bring, to shift their views if everybody else shifts their views. Studies noticed that because you have several rounds of elicitation, experts can drop out at any point, but they are more likely to drop out if they think that the majority position is different to theirs. And in interviews at the end of the Delphi method elicitation with experts, the experts say, well, I kind of disagree with the average, but the majority seems it's there. Okay, I'll agree with that. And you will find again another criticism has to do with the accountability, because especially if you ask the experts to apply self-weight and you say that, but if I assume if I just consider the subgroup of experts with the that think they know what they're talking about, I result with a better constraint probability, better constraint uncertainty. And the question is, okay, but it's what they said about themselves. It doesn't sound very rigorous. If something goes wrong and the uncertainty was much bigger, who is to blame here? It doesn't seem to be very transparent, that one. And of course, this method has no empirical control. It's all about the views of the individual experts and forming a consensus by asking them constantly to review their opinions in the face of what the other experts said. A behavioral approach is also the shelf method, the Tony O'Hagan method. In that one, 4 to 8 experts, not more, 2 rounds of elicitation, you lock them in the room for the second round, don't allow them to leave until you have a result. In the first round, they provide their views. You ask them to justify their opinions. And in the second round, they all meet in person. And through discussion, you end up with you construct an aggregated distribution. That aggregated distribution represents the view that a rational, impartial observer would have adopted in the light of the discussion and whatever data is available. Key challenge is the dominance of a persuasive but overconfident expert. What do you do about them? Well, you have to be very careful in selecting the experts. If you might have, I'm not sure how you know who to trust, but it's a known problem and it's difficult to go around. And of course, there is no empirical control. Now, we go to the mathematical approach, the Cook's method, as I said. Minimum 5 experts, but we can accommodate as many as you want, really. They're not expected to meet in person. It might be good, though, if you have any issues about your problem, whether it's presented clearly, if everybody is on the same page, to have at least some in the room to settle any ambiguities. I suppose that's true with all the expert elicitation methods. It's a mathematical approach, so you need some data to do this empirical control. How do you get this data? The facilitator, in collaboration with the problem owner, they have to go and search the literature and come up with questions relevant to the problem you want to answer, answer. And you construct, let's say, 15, 20, not more than 30 seed questions. And you ask the experts to provide a distribution where they think the true value of the question will lie. But you do know the answer. And by using this as by judging their ability to, assessing their ability to quantify uncertainty, you essentially aggregate their opinions by how well they perform to this test. If you want to say what is the problem with that, is the scoring scheme you may use. It's not like it's mathematical rigorous, and you combine their opinions using first principle maths or anything. It's a scoring system. Depending on how you use the scoring system, you get different results. But you would say that at least you think that the experts are not discussing the problem, are not persuaded by overconfident voices, are just having to give their honest opinions, the one they think that is more suitable for the more appropriate for the problem. I can give you some more details on how the classical model works, but we're 18 minutes. Would you like that, or yeah? The opinion is treated as the subjective probability on the likelihood of the examined event, and the empirical control essentially is assessed by asking the experts to give you, at most cases, the 93 values corresponding to the 5% probability, 50%, 95% probability. And you know the true value. So in some cases, it's going to be between 50 and 95% probability on that kind of interval, or it may be outside the interval, or it can be in the lower interval. An example of seed questions, given we're aerospace engineers here, most of us anyway. Can you judge, if you give me a distribution, again, 3 values, how many accidents do you think resulting in fatalities out of 140 plane accidents between 2012 and 2016 in USA? Something like that. I want you to give me an upper and lower value that you think will have 90% probability that your true value will be there, and a median, 50-50, to be above or below that. That kind of questions. So, a good expert will be one that will score high on, it will be well calibrated as well as informative. So, what does it mean? That in most cases, their responses will be within in 90% of cases, the true value will be within the 90% interval. However, the distribution will also be somewhat informative, because you may say that, especially if you have to give me a probability, I don't know, from 0 to 1, if you tell me that 90% probability 0, 1, and you covered absolutely everything, yeah? You haven't told me something informative. But you have good chances that the true value will be in there. So there are two scores that they have to score high: the calibration score and the informative score. So if you compare it with the uniform distribution, how informative is their assessment? Both scores are unitless, and both scores are in competition to each other, because in their attempt to, if they try to rig the system anyway, they try to give wide confidence intervals, but then they will score high on informativeness. If they try to be informative, you might be in this kind of situation where it's quite informative, but the real question, the true answer, is well out of that. Confidence interval. So calibration score is essentially, it's a p-value. If we say that theoretically the true belief of the distribution of, as we say, it's a subjective distribution, what the expert provides. If we say that in a theoretical way, if there were 100 or let's say 20 independently realization draws, you would expect that the distribution would be such that 9 of them would, only 1 would be outside the 5% percentile, and 95 percentile above. That would be another 1. 9 would be between 5 and 50, and the other 9 would be between 50 and 95. In reality, things will not always be so nice. It might be something like that, systematically below 50%, for example. And you want to see how good these two distributions are, how close what they actually did in the test is to that ideal one. And you use that divergence here. And then the calibration score essentially is a test. You have the hypothesis that the expert is well calibrated. If it's well calibrated, the calibration score is 0.5 or above. If it's less, it's not so well calibrated. Enough evidence to reject the hypothesis. However, it's not being used to screen out experts that perform badly. It's more like a score. They score well, they don't score so well. In any case, the calibration score is independent of the study. You use 20 seed questions. If you do another study on a similar subject, you can say the calibration score of that particular expert is this. I'm going to consult them only on the actual questions that I need their opinion. And you have the informative score, informativeness score to estimate. This one you estimate for its seed question. The question is, if you compare the density of the distribution to an uninformativeness background, like a uniform distribution, how different are they? And then you combine the two scores. You normalize them, and by linearly combine them, you estimate this one distribution that a virtual decision maker would have adopted. That's the one way to do it. There are more ways to do it, to do it a little bit more interesting, to optimize it a little bit. or to account only for the experts that performed above a threshold. In any case, though, you have the calibration score and the informativeness score. The calibration score tends to dominate the overall score. And so in many respects, I would say that because you do have these seed questions, you do have some data, you can do some sensitivity analysis on this data, you can use this data for its experts. It kind of gives you a comfort that you've done a good job, a defensible job. By using that for performance weight results, though, you're not always going to result in smaller uncertainty than if you used equal weights. I did this expert elicitation on a completely different subject some years ago, 12 experts. In one case, Cook's performance weights provide a very well-constrained uncertainty. In another case, it provided much wider uncertainty than the equal weights. All in all, though, you would say that you've done something that is defensible. After years of using this method, though, I mean, we've done the study, we published the results. Working with Scott, the question is, okay, you would expect that expert elicitation is the epitome of epistemic uncertainty. You don't know, you don't even have data. So how is this possible? All these 12 curves, essentially, to yield a very well-defined single one. And at least you would be able to give some kind of bounds that the shape of that curve could be higher or lower based on the experts. And I think I leave it here again.